Hi, we're Group 20 and we're going to be addressing Challenge 3 with our solution called RotaFlex. So upon starting the application, the user is greeted with a GUI with several input fields where they can specify parameters related to the data collection, as well as specify which exercise they want to do between reverse flies and sideline rotations. Upon clicking Submit, you'll notice that an image pops up on the screen instructing the user what position to stand in for 5 seconds to allow the sensors to calibrate and collect some baseline information from the user. When you click Start Calibration, this is clearly communicated to the user in a prompt, and after the 5 seconds have elapsed, the user will see a countdown instructing them when to begin repetitions of the exercise. You'll notice the ESP is housed within the dumbbell that the user is holding, along with one of the B&O sensors, and the second B&O sensor is housed within the on-body strap that the user is wearing. The second B&O sensor basically allows for corrections to be made based on back and torso movement, and how much back and torso movement we want to allow is actually one of the input parameters we specified earlier. The user will be doing this exercise for however long they specified through those input parameters, and in this case it was 30 seconds. After finishing the exercise, the user will have the option to show a plot which shows the angle at which they were able to raise their shoulder for each one of their repetitions. In this case, you can see that the user was raising their arm to about 90 degrees, and we can see that clearly displayed through the plot. A very similar process takes place if we were to specify parameters for sideline rotations as our exercise. Of course, the difference is that this time, upon clicking Start Calibration, the image that pops up is the calibration position for sideline rotations. The user can then begin doing repetitions of the exercise while also making sure to be wearing that on-body IMU to correct for any back or torso movements. And of course, we can click Show Graph to display a plot representative of the repetitions performed while doing the sideline rotations. We can take a closer look at this GUI here. So the user has the option to fill in parameters for either reverse flies or sideline rotations, and the parameters for each are the same. We have the duration of exercise, the increment between data points, which is basically specifying how smooth of a curve we want, and finally the reference check threshold for the on-body IMU, which we went over earlier. Additionally, validation is present on all of these fields, so the input box specifies what kind of units it's expecting, and if that's not the case, a submission will not go through. So upon a successful submission, the user is greeted with the screen where they can start calibration, but we've already been through that. One thing worth mentioning, however, is that the user can switch between exercises in a single session of running the application. So there's no data to plot right now, but if we were to have just completed reverse flies and open up our graph and now wanted to do sideline rotations, the user can do that. So first, we can put in some parameters for sideline rotations, and the program first checks to see if the current plot has been closed. As you can see, it instructs the user to please close the graph. Once that's been closed, we can now go through the procedure that a user would go through to produce a plot for sideline rotations. And as you can see, this graph is now representing repetitions the user would have completed while doing sideline rotations. One final thing to mention is that each run of the program produces a text file of the data being reported from each of the sensors and subsequently the data being plotted to the graphs. Any instances of the user's back or torso movement exceeding the specified threshold will also be reported here. Reading this gives someone the opportunity to conduct further analysis if they choose to, and to understand the quality of the data that they're looking at by verifying that each repetition of the movement was done correctly.